Hey everybody, and welcome to talking about conditionals and biconditionals with me. Today we're going to mathematically establish consequences using our understanding of the English language. So right now, all we've done is we have connectives that are just kind of like static. They don't really imply anything about each other. For instance, if I have the proposition, I got paid, and I have the proposition, I can't afford rent, and I put them together with an and, that would say I got paid and I can afford rent. Now you might assume, oh, the fact that she got paid means she can now afford rent. That's not what I said though. That is not logically sound. We don't have the tools for me to tell you getting paid will cause me to afford rent. So that is the first thing that we're going to do, is we're going to get a new tool for our toolbox. So let's say that P and Q are propositions. The conditional proposition, P arrow Q, is the statement if P then Q, and it is false if P is true and Q is false. Otherwise, it is true. We'll talk about the truth table for this in a second. But the important part is this is allowing us to introduce consequence to our formal mathematical language. Now I can say, if I got paid, this would be P, and this would be our, we'll say, assumption. Then I can afford rent. This would be the consequence. And the book has like fancy words for this, but I really don't care about the fancy words. I care about you understanding what this means. And you should really go read page 14 again, because that has like a long list of a bunch of different ways to say if then. Okay, so truth table. Why does it work this way? So I said it is false when P is true and Q is false. And then it was true otherwise. Explanation. Let's say that I made a promise. This case would be like I made the promise. That would be P is true. So P is my promise. And Q would be keeping my promise. So if I make the promise, that would be true. And then I keep the promise, that's true. Then I made and kept the promise. So one might say that I told the truth. Okay. Now, if I make a promise and then I don't keep my promise, one might say I broke my promise. And that would be equivalent to saying what I said. So my promise, what I said, was false. So overall, it is false. Now these next two are like, kind of get into a like, maybe that's not what I would have done. Basically think of it as I can't break a promise. Can't break a promise that I didn't make. So if I don't make a promise, means by default, I'm not a liar. So there you go. If you don't want to be a liar, just don't make any promises. If we want to think about like logically, you can if your assumption is false, you can conclude pretty much anything in a true way. If you did the little practice assignment, I said, I have a kid, all kids are blonde. Can I conclude my kid is blonde? Yes. Yes, I may conclude my kid is blonde. That is a true statement based off that information. However, the starting assumption was not true. Not all the kids are blonde, but based off that information, it was true. Okay. So besides those two like appeals to your intuition, when we talk about biconditionals, it's going to become very evident why it has to be defined this way anyway. So moving on, we're going to talk briefly about converse, inverse, and contrapositive. So let's say we've got the original statement, if P, then Q. If I got paid, then I can afford rent. The converse is where you just switch the position of Q and P. So I can afford rent. If I can afford rent, then I got paid. That is not necessarily like true. Maybe I had enough savings that I could pay rent. I maybe didn't need to get paid in order to afford rent. That is not something you can conclude from this original statement. So whether or not the converse is true is like absolutely unrelated to whether or not the original statement is true. Okay, inverse. Not P, then not Q. So that would be if I didn't get paid, then I can't afford rent. This basically has the same message as the converse, but again, it's not really the same thing that the original statement has said. We cannot conclude this based off the original statement being true. Contrapositive. So we flip the order and we negate both of them. So it's kind of like converse and inverse combined. So if I cannot afford rent, then I didn't get paid. Notice how this one is true. If I got paid, then I can afford rent immediately implies, well, if I didn't do it, if I can't afford my rent, then I must not have gotten paid because I made the promise, if I get paid, I'm going to pay I can afford my rent. Okay. So we'll come back and we'll visit contrapositive in a minute. But for now, let's introduce biconditionals. So biconditionals just makes your arrow go both directions. So we have a biconditional statement, P, both directions, Q, is the same thing as saying P if and only if Q is true when P and Q have the same truth value and is false otherwise. It is very common notation to use if and only if with two I's. Okay. So looking at this truth table, just based off what it says or what it looks like. Let's go off of what it looks like. It kind of looks like you've got P implies Q, and you also have like Q implies P. That would be like the left direction. You might want to naturally assume just from the notation that these two things are going to be equivalent. And in fact, you do get that. You are going to prove that on your worksheet. Congratulations. Are you so excited? It is not possible, though, if we had defined the conditional slightly differently, where like we had both of these be false. for the conditional. So keep that in mind while you're doing your worksheet. Be like, oh yeah, if this was false here instead of true, then this wouldn't be working as a two-way street anymore. Okay. So, and then just another aside on biconditionals, note that it's only true when P and Q have the same truth value. So basically it just imposes logical sameness on P and Q. It's kind of like a logical equal sign. So for example, if I were to say, I will take a shot if and only if I have a meeting, means that going forward, I will take a shot implies that I must have a meeting. And then going backwards, that means like I have a meeting, so I'm going to take a shot. So I take a shot for every meeting is basically how that gets interpreted. Okay, don't worry, it's not true. I take shots all the time when I don't have meetings. Okay, so back to contrapositive. I promised we were going to talk about this. Okay, it applies to conditional and biconditional in the same way. So we've got statement, and then remember you want to flip it backwards and negate it like that. And then same works with the biconditional. Remember how I pointed out, hey, like this statement is true for the conditional? That holds in general. And then so does this one. And let me prove that for you. Okay, so the first equivalence says P then Q is the same as not Q then not P. And let's go ahead and prove that. So we've got P then Q. And what we do not have right now is that is equivalent to this statement right here. You will prove this on your worksheet. And so I'm going to just go ahead and say by worksheet. You guys will prove that for me. After that, what we can do is we can go ahead and swap which side the P and Q are on. So we can say Q or not P. That's using commutativity. I always pronounce that wrong. That's using commutative. And then we can use double negation to put a negative on our Q. And then this gets us back to using that again. It's going to be equal to not Q implies not P. Here, not Q is sitting where P was sitting, and not P is sitting where Q was sitting. Okay. So once again, by worksheet. So that's the first one. And then let's go ahead and do the second one, the biconditional. Like, it's pretty easy to see, in my opinion, that this is going to hold. Okay. So, sorry, I meant to write that in black. Proof. So we start with P implies Q if and only if And then, again, we're going to use something from the worksheet that you haven't proven yet, but you will. So that's by the worksheet. We already talked about that a little bit. All right. And then the next equivalence we're going to do is we're actually going to use this guy right here. So we're going to do not Q, then P, not P, and not P, then not Q. So we used this guy over here for both of these. And then we just use the fact that it's an and symbol and we recombine. So not Q, if and only if not P, by worksheet, where we use basically just that again. Okay. There we go. Contrapositive is actually just another way to say the same statement, logically at least. Quick note, you cannot say anything about the inverse and converse of the original statement. There's no logical equivalence there. Okay. There we go. We have introduced consequences into our mathematical language. And that's all I have for right now. See you later.